Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is one MCQ and the question is in front of you. Which of the molecule have lowest barrier for rotation about the indicated bond? I mean here you can see this one in CC single bond rotation they are asking. By the way, I request everyone please pause the video, try by yourself and whatever answer you get please write in the comment box along with few words as explanation. Don't worry, you will have your right answer with explanation after some time. Now I believe you have tried, so let's start. Now, if you look at which of the molecule have lowest barrier for rotation about the indicated bond, by the way, all are single bond, and we know CC single bond rotation allowed because CC single bond is nothing but a sigma bond. Actually, by the way, if you look at conceptually, sigma bond could be formed by SS, SP or PP by end-to-end overlap or head-on overlap, and the electron density is exactly in between the two nucleus. Okay, so if you rotate this bond, the electron density will remain exactly at this position, so there will be no problem in CC rotation. Whereas if you look at a carbon-carbon pi bond is formed by parallel or sidewise overlap of p orbital. Now if you plan to rotate this, then the overlap will be disturbed, the bond will be broken, so pi bond rotation or CC rotation of the pi bond is not allowed. Okay, now if you look at here, then you'll say, sir, this is CC bonds rotation allowed? Answer is no. Why? Because rigid structure, because it's a ring compound. So if you want to rotate it, this rigid structure will be broken and it will cause severe angle strain. Okay, so that's why this rotation is not allowed. Now if you say, sir, option B, it is CC single bond, it should be, answer is no. I'm drawing one of the canonical form, so this bond can come here, it can open. By the way, another one canonical form also possible, but the outcome will be similar. Positive charge here because this bond is gone and there will be a negative charge. By the way, in this case, you can see there is a partial double bond character. So CC rotation is not that much allowed, like option C. Here CC rotation is allowed. So because of partial double bond character in option B, this rotation is to some extent restricted. Fine. Now you have to compare option C versus D. Now if you look at, let me draw it in a Newman projection. So I am drawing the most stable one, that is staggered or anti. So this is CH3HH. By the way, what I am talking, by the way, I am drawing C2 versus C3. So this is C2 and the behind one is C3. So here also this is methyl opposite, hydrogen, hydrogen. Now if you say you have to rotate, then there will be instantly methyl hydrogen rotation or methyl hydrogen in any direction if you go. This is, now if you look at in option D, it should be like that because I'm talking C2, C3 allow. So C2 has 2 methyl group and C3 case it also has 2 methyl group. Now one thing you can expect that, sir, there is actually, by the way, this is the one of the orientation I'm drawing. You may draw different also. Now if you want to rotate, then by the way, since one hydrogen is replaced by one methyl in both cases C2 and C3, so the rotation, if you want to do, this gauche butane interaction or the steric repulsion will be more. So obviously if the steric repulsion is slightly more, then the energy of activation will be slightly higher, then the rotation is to some extent restricted compared to option C. So now if you look at in option C versus D, they are purely single bond, so technically this CC rotation is very much allowed, but C case it is very less, the rotational barrier for this C2, C3, this CC rotation. Why? Because the gauche butane interaction or the steric repulsion is pretty less compared to the option D. So what will be the answer of this problem? Option C is the right answer. Okay, so what if you get this question in your exam hall, how could you solve it less than 30 seconds? Lowest barrier for rotation about the indicated bond, ring compound not allowed, partial double bond fixation not allowed. Now C versus D, how could you complete? This is actually more bulky, so CC rotation will create more steric effect, higher energy barrier. Option C is the right answer. Okay, now what you have learned today from today's video, CC sigma bond has free rotation, means free rotation is allowed in this case in acyclic compound. Cyclic compound is not allowed. But if you look at pi bond, it is not allowed, because in case of CC bond rotation, the pi bond will be broken. Okay, and this is the overall discussion. Thanks for watching. See you in my next video. Bye bye.